Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you once again what to look for in the night sky. This time we're talking about the week of January 31, 2022, so basically the first week of February. And we've been talking the last few weeks. If you've been watching these videos, and I can't imagine why you haven't been watching these videos, but if you've been watching these videos, we've been talking a lot about the planets because the planets have been spectacular in the last few weeks, the last few months. And we've been watching the planets in the evening sky scoot out into the morning sky, disappear into the sun. Saturn is gone now, hasn't quite appeared in the morning sky. Venus has, so it's joined Mars in the morning sky, so you can see Venus and Mars. Mars beautifully there in the Scorpius-Sagittarius region of the sky, over into Sagittarius, and Venus further east from there. But those are great in the morning sky. We still have Jupiter in the evening sky. So this week, we're going to, sooner or later we'll stop talking about these planets, but I don't know when. This week, if there's one thing not to miss in the week ahead on February 3rd, Wednesday, so that's February 2nd, Wednesday, February 2nd, on this week ahead, what you want to see on that evening is a very, very slender crescent moon, a waxing crescent moon. It's only going to be about 4% illuminated. So this is about the thinnest of crescents you're going to see, and it's going to be sitting right below Jupiter. So go out in dusk, use your binoculars if you need to, if you want to pull these things out, but look for Jupiter making a fantastic pairing with the slenderest of crescent moons on this evening of February 2nd, Wednesday, February 2nd. We got that right. So there you go. Go out and check that out in the evening. Once it gets further dark, all night long right now, the constellation of Auriga is in the evening sky. And Auriga sits above the head of Orion. So if you're familiar with Orion, if you know the belt of Orion here, and there's the shoulders of Orion and the legs of Orion, Rigel and Betelgeuse. Take the size of Orion, about 20 degrees, the size of Orion from Betelgeuse to Rigel, and move up that same distance, and then go a little bit more. And more or less directly up from Rigel is going to be the bright star Capella in the constellation Auriga. And this direction here, so one of the interesting things above the head of Orion in Auriga here is the anti-center of our galaxy. So now when you're looking at this part of the sky, this is something to keep in mind as you're doing this observing this week. When you're looking at this part of the sky, you've got your back turned to the center of the galaxy. It takes us 235 million years to complete an orbit around the center of the galaxy. And so picture yourself on a big merry-go-round, and now you're sitting on the outer edge of that merry-go-round with your back to the center of the merry-go-round, the axis of rotation of the merry-go-round, and you're looking at the anti-center of the galaxy up here in Auriga. So that's what we got going on here in the evening winter skies. Again, this is up all night, basically. You go outside and you see it. It's really well placed for mid-northern hemisphere observers like myself. And so find Capella. Capella's a very bright star. Capella's a 0th magnitude star. Remember, the stars count backwards in brightness. So magnitude system counts backwards. So 0th is brighter than 1st magnitude, is brighter than 2nd magnitude, factor of 2.5 step in each one of those magnitudes. So 0th magnitude star puts Capella among the very brightest stars in the sky. So we blow this region of the sky up over here, and Auriga looks something like a kite, a diamond shape, or a kite like this. Capella's up here. You move across to Minkalanon Beta, the beta star. Capella's the alpha star. This is the beta star. This star is still brighter than 2nd magnitude. So this is a nice bright star. It's an eclipsing binary star, like we study in our star cluster field upstairs here. And so this eclipsing binary star, 2 stars, 1 star, when one passes in front of the other and blocks the light of the star. So you see these things eclipse. Pretty short period, about every 2 days, about every 48 hours, this thing eclipses, but it's not much of an eclipse. It only gets 10 or 15% fainter in eclipse. And so you'd have a very hard time observing that. But if you want to try, you go ahead and try it. You need to do that with a telescope and have pretty good companion stars to compare it to. Much better task. If you got a telescope with a camera attached to it and you want to try a project there, this would be something to do is to take pictures of Beta Auriga here and watch Beta Auriga going into and out of eclipse. And so I, measure the brightness, normalize your field with other stars that you have in there and see if you can measure, if you can detect this star getting fainter relative to those other stars. Would be a very fun project for you. We continue on down here. Theta is this star. Now we're at 2.6 magnitude, so we're still pretty bright, but we're between second and third magnitude for both Theta and Iota down this direction. So these are fainter stars than Alpha and Beta up this direction, but still good and bright and relatively easy to see. This region of this star right here is a double star. So this is one that you could actually see with your small telescope. So you slide your small telescope down this direction and look for this double star right there and see if you can pull that out. And on down to Iota, and then back up to Capella. And as you move back up this direction, you come across a triangle of stars that's often called the kids. Okay, and this triangle of stars is Eta, Zeta, and Epsilon Aurigae. Epsilon Aurigae is one of the most studied, one of the most famous, interesting of stars. It is a star that goes into eclipse, like an eclipsing binary, but only every 27 years. So every 27 years, it wasn't all that long ago we passed. I say that, and time just goes, we may be halfway to the next eclipse by now. We may be more than halfway to the next eclipse by now, because I remember this eclipse very well, but who knows how much time has elapsed since that actually occurred. And so anyway, the best model, really, we know that there's a companion star there to the star that we can see, and we know that it's faint, and so it's got to have a big dust cloud there, and people have been working on this and modeling it and waiting for eclipses to come so they can get better data to look at this more. Our best model right now is we have a binary star system in orbit around the other star that we see, and there's a big dust cloud around that whole thing, and you see that dust obscuration of Epsilon Aurigae every once in a while. Zeta is also an eclipsing binary with a pretty long period. It's got about 2 years for eclipses there, and then this will eclipse for a month or two every 2 years. So I don't necessarily recommend that as an observing project for you, but try to find these 3 stars that make up the kids in Auriga and see where you are with those things. And so this is the stars that you want to be looking for. There's also open star clusters in this region. I want to make sure I got those numbers right. M38, M36, and M37. So M38 falls right here, M36, and M37. So right across here, you'll find open star clusters. So M38 is the one that's almost on the line between Theta and Iota, and then M36 and M37 across this direction. Those should be visible to you in binoculars. So you should be able to see those and pull those out. Start about halfway between Theta and Iota and see if you can find M38. Nice, bright, glittering open star cluster. Lots of stars right there. Find those with your binoculars or your small telescope. Drop to M36 and then over to M37. So see if you can find these stars. Think about all the interesting things going on here, particularly eclipsing binaries. This is, this is about some of the interesting eclipsing binary systems that we have in Auriga and the open star clusters that are there. And enjoy observing that. Don't forget on Wednesday evening to go out and check the very slender crescent moon near Jupiter. It should be a good observing week. I hope you have a good week, everybody, and we'll have something new for you next week.